So this is the beginning of 2 sessions on the OpenFabrics interface, OFIWG. The first one from me, kind of laying out the context of the working group, where it came from, how it's structured, how it's organized, what we're trying to accomplish, and so on. And the next session after that is Sean Hefty, my co-chair from Intel. We'll be discussing more detail of the framework itself. So you sort of get an in-depth look at the OFIWG, where we stand right now. What I want to do is just, again, a brief overview and a status update. Some of you who in here, I talk to you people on the phone a lot, but I know almost no faces. Who here participates regularly in the OFIWG? It's about what I thought. I thought it'd be about half the room, so we're pretty close there. Want to keep everybody on the same page where we are and where we're going. You know, and to do that, you need to know where we came from. So for those who have not been tracking the OFIWG closely, this is your chance to catch up. And I also wanted to use this as an example of a possible model for the OFA going forward. I talked about that in my session this morning. I'll spend just a little bit of time on that, not too much. Quick agenda, we'll talk about the framework working group, what this concept of a new framework actually means, the 2 guiding principles that seem to be driving us, current status, process, and participation, and maybe just my quick snapshot of the couple key issues that are facing us. This all started last August. The OpenFabrics Alliance OFA undertook this effort to challenge the current paradigm for high-performance I/O, which we all know today is verbs running over some form of an RDMA network, predominantly IB, but it could be Rocky or it could be iWarp, something like that. So in order to address this new paradigm, what the OFA did was charter this new working group, which at the time was called the Open Framework Working Group, which has since changed its name. And it gave it this specific charter. And it's interesting and worthwhile to understand the charter in detail. I'm going to read them in reverse order. The second was an extensible open source framework that provides access to high-performance fabric interfaces and services. So there's this notion of a framework that contains something, and the something that it contains is the first bullet there, extensible open source interfaces aligned, importantly here, aligned with application demands for high performance fabric services. In other words, we needed to be very sensitive to how people were going to use these APIs, make sure that they were responsive to what applications were doing. That was the charter. The other part that I haven't shown here, but that is actually part of the charter, is we are not defining new network standards. That is, always has been, and remains the purview of other standards bodies like the IBTA or the IETF or so on. It's not our purview there. So put that in really simple terms, the charter was, at least my interpretation of it was, we're going to define a series of what I called API-lets. In the sense that it's not one large API to rule them all, which I think is the direction we've historically gone in the past. We're all looking for the Nirvana API that does everything really fast for everybody and is cheap, simple, and easy to use. And I think the recognition here is that that's probably not the right approach. Instead, what we're looking for is a series of smaller, more focused, well-defined APIs. And if you're going to have this notion of these API-lets, as I call them, you have to have some way to support them, some framework that supports them. That's the notion of the framework part of this whole thing. Objectives that the OFI started out with, really pretty straightforward. Maximize application I/O effectiveness, or application I/O effectiveness. In other words, how well does the application work on the network? Not just application effectiveness in general, because I can't do much about that, but I can sure help from the network or the I/O side. So that was the first objective. Second was excellent support for a wide range of what I call classes of applications. I used to say just plain applications, but if you think about it again, this notion of applications is a big gooey tarball. So break it down into excellent support for chosen classes of applications. This is that whole notion of application-centric I/O coming back at us. We should be driven by what applications need. Minimize interface complexity and overhead. This is a code language for verbs are heavyweight. So you hear that said all the time, and I understand where that complaint comes from. We wanted to avoid that. The interfaces need to be extensible. This is this notion of if you've got these little API islets, they all ought to be able to work together in a composable way to create something that's usable to the application. And most important, not most importantly, second most importantly, it's not constrained to a particular wire. So we did not start, as we did with verbs, with InfiniBand and say, let's build an API for InfiniBand. What we're saying is, let's build APIs that work over one or more networks of interest. I'm not saying what those networks of interest are. That's not our role here to say that. Our role is to come up with APIs and service providers that will work over a number of networks of interest. Let me just take a moment and go back to my favorite canonical diagram. I really don't like this picture very much at all, which is why it shows up in about a third of my slides. But you start looking at the verbs-based framework. This is the framework that we had today. You know, when people talk about the verbs framework, this is what we have today. It essentially consists of the application layer at the top. It consists of fabrics at the bottom. And then in the middle is the verbs framework itself, all the stuff with which we're all terribly, terribly familiar. It consists of an adaptation layer, a series of ULPs, and importantly, this part here, it consists of lib verbs, where it contains, I think Sean told me, 60 function calls. This is sort of an important observation. 60 function calls is a lot. If you stop and think about it, most applications probably use half a dozen, maybe. 60 seems like a lot. There's a clue here that we've been down the wrong path with verbs. There's maybe too much complexity for what we're trying to accomplish. And then, of course, there's a series of kernel services. That part in the middle is what I call the open source zone. It occurred to me the other night as I was working on these slides, people say all the time, how do I make money in open source? Well, you don't. What you're doing is you're supporting applications at the top. That's where innovation occurs. And you're supporting fabrics at the bottom, which is where innovation occurs. You're not selling anything in the middle. We are an enabling organization. We are not making anything that we can sell and make money on. What we're doing is enabling applications to run over fabrics. That's what we're doing here. So the open source zone. If you take a look at the Verbs API, it closely parallels the semantics that were defined in the IB spec. I think we all know this. This is history. So InfiniBand was invented, and what came along with that was a series of services and a series of semantic descriptions that described the way those services work, which in InfiniBand specification terms happen to also be called verbs. Sometime later, that semantic description was converted into what we now know as the Verbs API. The corollary to that is that the Verbs API, as we know it today, is very tightly connected to the underlying hardware on which it's based. So it very closely represents the set of services that are defined in the InfiniBand specification, reliable, connected, unreliable, datagram, and so on. It's very closely connected to the hardware. If you think about it, that's pretty much the polar opposite what application developers want. What they want is something that is abstracted above the hardware. So really great where we started. What we may have learned here is that we were too low level in the stack as far as being too close to the hardware. The basic abstraction that's exported to an application is a queue pair. Again, I mention that because it's a representation of the fact that the the Verbs API is really closely related to the underlying hardware. The central construct of the InfiniBand architecture is a queue pair. That's a great construct. The question is, does that need to be exposed to the application or not? This queue pair is configured to provide some set of operations based on the set of services that are available from the underlying fabric. And we've done some backflips with other fabrics in order to make those services available on those fabrics, even though they didn't natively support it. So low-level details are also exposed to the application layer. And in some cases, those low-level details are of interest. In most cases, or many cases, they are not. So we may be exposing too much to the application layer beyond what he really wants to see. Here's sort of a diagram that illustrates that. There's one giant service provider, that thing shown in that black box in the bottom, that provides a number of services. The number of services are available over a couple of different kinds of wire services, reliable and unreliable. So there's a number of things. I haven't been exhaustive here. I'm just trying to make a point that you get them all or you get none. There's really no middle ground. You know, you either get unicast service and you get multicast and you get, you know, on and on and on. That's what you get. And it's all accessed through this one API to rule them all called verbs. The whole thing is sort of funneled through this notion of a queue pair. So you can see this is what I'm trying to get at when I'm saying that the APIs right now are very close to one large I/O service that's provided. And you can see where the complexity comes from. If through the API you're giving the application access to a number of different services, that immediately implies, as you guys all know, a zillion branches through the code to select the kind of service that you want. There may be a better way to do this. Oh, one other thing I wanted to mention, notably absent is anything called a collective service, the original InfiniBand. There were a couple of vendors who came along and solved that problem, but what that said to us was, the message was, you know, we didn't get something right the first time and we need to do better the next time. So a single API, this is an observation slide that Sean came up with a long time ago. And it's really stuck with me because I think he nailed it, you know, right on the head when he came up with the slide. But a single API really cannot meet all requirements and still be usable. You know, the 60 function calls in order to get what you want, one function. You know, having to pick your way through that is just not a tenable approach. Any single app really only needs some small subset of a single API, the way it stands today. In other words, the services that he needs, he's generally using one service, maybe two services, maybe a combination. But he's not using all of them. He's not using all the richness of them. And all that richness, all that desire to be everything to everybody produces a lot of complexity that winds up burdening everybody, particularly people who are trying to do relatively simple, straightforward things. So there's always going to be extensions required. There is no single correct API. There just isn't. There won't be. It can't be. And we need more than just an updated API. We need this notion of an updated infrastructure. So this sort of summarizes, in my mind, it falls into the category of, you know, a problem well stated is well on its way to being solved. This, to me, is the statement of the problem that we've been wrestling with verbs for a number of years now. So that leads to the idea that maybe we can streamline these APIs, provide a richer set of services. So on that previous slide, you know, I showed the set of services. We're limited to whatever set of services are defined by the wire today. That's it. You don't get any more than that. But the question is, can we provide a richer set of services which are better tuned to application requirements? Bob Ciotti, I'm looking at you. This is why we're going to be talking as time goes on here. And the approach to that is to broaden the number of APIs. So rather than this one single API, this notion of API-lets, as I call them in a diminutive way, although I don't mean it to be that, but you streamline each one by reducing the functions associated with it. In other words, if you have a function that you need to perform, provide an API for it in the extreme, in the limit. I mean, obviously we're not going to that limit, but you can sort of see what we're doing here, a relation between an API that gives you access to a specific I/O service, like send or receive, something like that. Each API represents a specific I/O service, and there's the expectation that the APIs are composable. So if you have an application that needs to do both sends and receives and large bulk data transfers, you would use two different of these small APIs, if you will. I hate to keep calling them that, so I'm just going to call them APIs from this point forward. And abstract the low-level fabric details that are visible to the application. Some things applications want to see, some things they don't. We're going to be in a knife edge here. Some applications really want to see the low-level details of memory registration, and some just don't. So I don't know yet that we've quite wrestled with how we're going to solve that dilemma, but wherever possible, the idea is going to be to abstract away the details of the fabric from the application. Things he doesn't need to see, doesn't want to see, and shouldn't have to see. That leads us to a much different model that you can see here, where there's a number of interfaces, so to speak, or APIs if you prefer, each of which accesses some I/O service or other. And I've just listed, you know, for mapping purposes, the same set that we showed in the previous slide. But this set could change as a function of what we discover applications need as we go forward. In some cases, we're finding out that the service is right, but it needs to be tweaked a little bit. In some cases, we're finding out, as though it weren't already obvious, that there are some services that are just plain missing, for example, collectives. So this is sort of where we're going with the OpenFabrics interface model. It consists of these two large pieces, the so-called fabric interface part, shown in the green box there, which is what we spent most of our time on to date, and then the fabric provider layer down below, which is some combination of hardware and software that provides the I/O services that are defined by the set of APIs in the fabric interface layer. So this whole idea of a framework, it exposes a number of I/O services, and I listed them there, what they might be. I don't know that we have the definitive list yet of what that set of services is, but that's the nice thing about that approach. We can add services as time goes by. We're not limited to the specific set of services defined by whatever the wire happens to be. And they do that via a series of defined interfaces. Important notes in the gray box there, things that I really want people to see. I put in small text in gray boxes at the bottom where you won't even notice it. But this is where innovation occurs. Remember I said that what open source does is it enables innovation at the application layer, and it enables innovation at the fabric provider layer down below it for people who are actually building hardware. This is where people get to innovate, where vendors get to innovate on what services they want to provide. Some particular company may decide that whatever service, whatever market it's serving really thrives on collectives. So they may optimize the living daylights out of their collective implementation and give us a provider that is really great at collectives. And somebody else may say, collectives aren't that important to me, but small message transfer is. I'm just making this up. I don't know. So he may choose to implement his collectives in software and do it in a less optimized way, but I really focus on, so you can see where I'm going with this. There's lots of room here for innovation in the marketplace. Okay, scalable fabric interfaces, what are we doing here? What's implied by incorporating these interface sets in a single framework? The alternative was to not put them in a single framework and just leave them out there as APIs that could be accessed. And again, I stole this slide from Sean, so if I butcher the life out of it, it's my fault, not Sean's. But if you did that, what you'd wind up with is a series of interfaces that turns into a hugely complex DL open problem. So you would accomplish what we were trying to accomplish, but you would have created a living nightmare for yourself in the process. And that's what gave rise to this notion that really what we're after here is a framework that supports all of this stuff. It supports the set of interfaces as well as the set of I/O services that we're looking for going forward. So guiding principles, what is the OFI-WG using to drive itself forward? There are really two, and I think this is becoming obvious both from what was said at last year's workshop and what's been said so far today. The two are this notion of application-centric I/O. We're going to let ourselves be driven by what applications actually need going forward. What a concept. The other is fabric independence. So we're not starting with a fabric and building an API on top of that. We're doing this very much tops down, which is very different from the classic bottoms up kind of approach. So the two guiding principles that are driving us here. This is a slide from last year, what we mean by application as driver. You examine the classes of applications that are important to target users of OpenFabrics. So this is that notion of classes of applications that I've been describing. We needed to break that application space down into bite-sized chunks. And we've been marching our way through those classes of applications and actually querying those communities and saying, what do you need in order to make this work? And we had about a 5-week dissertation, literally, from the MPI community on this is things that you could change, that we need to make ourselves really effective. That kind of input is just absolutely invaluable to the OpenFabrics Alliance as an organization. We let the applications drive the appropriate interface definition, and that in turn should drive the necessary features at the underlying I/O service provider layer. So what set of features actually need to occur at the provider layer in order to meet the needs of the API? What's hidden in here, but I haven't said, is that may result in changes at the standards layer. So I could imagine the InfiniBand Trade Association, for example, looking at the APIs that we come up with, looking at the definition of the I/O service provider and say, we could make that better if we change the wire protocol to support that. So you may, if we're lucky here, we may start to see some change that the standards bodies and therefore the underlying hardware may begin to follow us. That would be good if it happened. One thing I wanted to say, only because this comes up a lot, there's a couple of people who really have a hard time with this, but when I talk about application and application-centric, that, you know, people sometimes think, you're talking about Flowdyne, right? No. What I'm talking about when I say application is very much in the context of the OSI reference model. The application is whatever it is that consumes the I/O services that we're providing. So there's all these endless discussions about, well, is MPI an application or middleware? I don't care. For our purposes, MPI is an application. From the network perspective, it consumes network services. Think of it as an application. I just wanted to get that clear so we don't have to have that discussion anymore. Rigorously speaking, this is the definition of application, and this is the what works. All right, enough of that. For example, what do we mean by applications? Well, I don't want to belabor this list. We've already seen it before. Sockets-based applications, various kinds of distributed computing models, file systems, block storage, and this class called data analysis. So those are the classes of applications we're talking about. I talked about it an hour ago, so I won't spend any more time on that one here. Wire independence. Remember I said there were two guiding principles. One was be driven by applications, and the other was be wire independent. So we spent a lot of time so far in the OFI working group working our way from the top down. And that's helped us to define both what the APIs might look like from a strawman perspective and what the framework might look like from a strawman perspective. The next thing that we need to do is to test this against various implementations. So what would this be implemented over? So for example, there's a session, I think we'll be talking about this in the face-to-face meeting tonight. What does it mean to map this stuff over a Genie, let's say, a Cray API, a Cray provider? What does it mean to do this over InfiniBand? What does it mean to do it over Rocky? How well do those things map to what we're trying to do? So what I'm suggesting here is when we're defining the APIs in that green box that I've left blank, we want to keep ourselves honest. Make sure it works from the application perspective and make sure it's implementable from the wire perspective looking up. It's no good if we come up with great APIs that are not realizable in any practical network today. All right, so there's really 4 activities going on in the OFI working group, sort of in no particular order. There's Live Fabrics itself, and this began with a proposal from Sean, a strawman proposal for what the framework would actually look like, and I'm hoping he'll talk about that more in the next session here. There's this set of applications and application requirements that are driving us from the top down. Again, we've been marching our way through classes of applications. Now we're starting to think about what the APIs might be to reflect the needs of those applications. There's the service providers themselves, and then there's the actual definitions of the APIs. And I'm making reference again to this notion of OFA interest groups. We'll see if that actually pans out or not. In some sense, we're prototyping this notion of an interest group in the OFI WG right now because of this close relationship between the application providers at the top and those of us building network stacks at the bottom. A couple of issues that seem to have boiled up. I haven't put a lot of thought into this. I know Sean has put a lot more thought into it. He's gone through many of the presentations from the application group so far and sort of collected them all together. But sort of the high-level buttons that I saw, and I'm sure I've missed about a dozen more, but memory registration seems to keep coming back as an important issue. The question isn't so much whether you need to do memory registration or not, but how much of it you expose to the application and how much of it do you hide in the provider layer. This may well be one of those where there's no right answer. There are some applications that really want to see memory registration and control it directly, and some that just don't. So this is going to be an interesting topic of conversation going forward. Collectives keeps coming back as an operation there that we need to do more with. Given that InfiniBand never defined collectives in the first place, that gap was filled with other proprietary solutions from, say, Intel PSM and Mellanox MXM and so forth. We need to do something about that, both at the API layer and at the I/O provider layer. I missed on here, atomic operations is in that same category. InfiniBand defined some set of atomics, but it's clear we need to do better there. Another one is completions. So how are completions signaled back to the application? Turns out to be sort of an interesting point of discussion. And there's several more. I didn't mean to try to be exhaustive here, but just to give you a sense for the level of the conversations that we're having right now. We're at the point where we're beginning to grapple with these kinds of topics. Okay, process-wise, the OFI WG, it works in an open source way, just like the EWG does. That means anybody is welcome to participate. There are rules about who gets to vote and under what circumstance they get to vote. We haven't had to vote yet. Maybe we won't ever have to vote. Don't know. But we did put work group processes in place in the beginning that would allow us to continue to make progress if we run into these areas where there's a lot of contention and no good way to resolve it. So it's sort of contrary to traditional open source methods that work mostly in consensus. But then again, that's because we're in a different realm here. We are not building an API, based on an existing standard. Therefore, we're in sort of a different world, and that required that we have a set of processes that we've not had to use before. We'll see if we need them or not. All are welcome to participate. The more the merrier. We've been getting, I don't know, between 20 and 32 participants weekly at our conferences, which is astonishing to me. I'm shocked how many people think this is interesting and are showing up, but I'm really gratified by that. There is this face-to-face meeting tonight. That arose serendipitously. You know, we were having a work group meeting a couple weeks ago, and it's like, hey, we're all going to be in Monterey. Let's have a face-to-face. I said, well, that's a great idea. So we started assembling a bin list of things we could talk about at the face-to-face. And that bin list quickly exceeded any possible available time. So we got about 3 weeks worth of face-to-face stuff to talk about in 2 hours tonight. So we're going to try to limit that to just the most interesting face-to-face topics for tonight. Okay, so that's it. All I have to say. Any very quick questions? We're a little short on time, so I don't want to spend a lot of time, but sure.
So when we have these API-lets, the functions in those API-lets...
Let's not propagate that expression, by the way. I'm sorry. That's my fault.
So the number of functions will again add up to 60. How is it different from what we today have?
I don't know that it's true that the number will add up to 60. I may have given you the wrong impression by claiming that there's a one-to-one relationship. There isn't, not necessarily. But the point is that you know that, you know, there may be 60 of these APIs, but you know you use 3 of them. You know, and you never use the other, 57. There aren't 57, but, you never have to pick your way through this steaming mass to find the 1 or 2 functions that you need.
Question.
Rich?
So, don't people do this today anyway on their own? Like, the first thing I did is Verbs program. It was write some higher level stuff that made it easy to open a connection. Like, it's just a lot of little stuff. So I wonder if there aren't existing, examples of doing this anyway among the community.
There may be. I wouldn't claim that there aren't. I'm not aware enough to know that there are or there are not. But the very fact that you had to do that tells me that there's an issue there and that we should probably be addressing that issue.
Yeah, verbs are kind of like assembly, right? It's really low level stuff.
That's right.
And nobody wants to write assembly language unless you really care about some very specific efficiency or capability.
And even if you do, it's not clear that Verbs is going to give you that. If you think about Verbs as assembly language in the way that you just did.
Never once said performance. Is simplicity the only goal?
No, performance is the goal. Equal or better than.
Equal to what?
Verbs.
Well, okay.
So
what's Verbs performance? I don't know.
But, I don't know that you can measure it, but, if you're going through all these code paths to try to figure out which function call you need, if you can eliminate that, by golly, it's got to be faster.
Well, I'd be real interested in what performance means to an API.
Mm-hmm. Good question.
That's going to be an interesting discussion.
Laurent?
Yeah, I just wanted to stress that OpenFabrics is only one suggestion in one group. It's not approved. And the notion of a framework is a good notion, but what we're missing is basically a lot of services that we have neglected during the years. So there have been discussions even in the previous session regarding better management of subnets, notions of managing reliability better that cannot be done in low-level APIs. This is what a framework should be all about. Now, there was also, just in the previous discussion, they mentioned the importance of interoperability. And you don't do that by shattering the basis of your fabric. The way that you achieve interoperability is that you leave the foundation well-defined, standardized. Currently supports 3 technologies. It could be extended. And you can build on top of that or add extensions as you need. You don't break down the foundation because otherwise you don't know what you get. Regarding the ability to innovate. Now that's a very dangerous expression when you're looking at interoperability. If a vendor innovates underneath your APIs, interoperability is broken. You can't connect an old cluster to an existing cluster. You can't connect your storage secure existing cluster.
Yeah, we discussed that at length, and there were quite a few presentations on that very topic last year, and the conclusion was that interoperability is a standards issue, not an API issue. So your point is well taken and not to be ignored. But on the other hand, I also think that it's a manageable problem. To your other points, I was pretty clear to say that the lib fabric that we're looking at now is a straw man. We are using open source process to come to consensus about what the right answer for the framework is going to be. I don't claim that I have enough insight to know, but I certainly know that what we're seeing now is reasonable and makes sense.
One last comment regarding APIs. Okay, so there are a lot of examples of very fundamental, what we call like assembly language APIs. The Intel instruction set gets wider and wider, breaking existing instruction sets. The NPI specification has 300 to 400 API calls. Each application chooses whatever it needs to use. And the same goes for verbs, and it's also been extendable over the years, right? Initially we had InfiniBand, and we added iWarp, and we added Rocky, and we have IP addressing for Rocky. We added support for user space networking protocols such as Ethernet checksumming, offloading, flow steering. This is something that's being evolved and strengthened, and basically whatever we need to do at the fundamental layer, we'll do that. And we should have better APIs that map better to the fundamental performance requirements at this basis.
And you'll hear a presentation from the TAC in a day or so talking about, how do we continue to evolve verbs going forward. There's a whole long laundry list of things that I think we'd all like to see verbs do a better job of. So that's not being ignored by any stretch of the imagination. One more question, then I got to get off the stage here and let Sean talk. Rich, I think you had one.
I was just going to make the comment. We talked a fair amount about collectives and wanting to keep it small. Like the API is small, so an API, the collective API is 40 to 50 functions, and it's an orthogonal. It's an orthogonal API. I would highly recommend against trying to do how open is those details and trying to address that at an API level, because there are a lot of things becoming implementation.
Yeah, and I didn't mean to imply again that there's this one-to-one relationship between every collective and a mini API to address it. Somewhere there's a fine line. There's a right answer that makes sense. I'm not the guy to say what that right answer is, but that's the direction we're going. We need to add collective support, and we need to add an API to access that collective support. However we do that. Maybe not. Maybe not. And again, I'm not dictating here. This is what the framework working group is wrestling with. By all means, let's have proposals come into the working group. Let's debate them and talk about them in our meetings and see what comes out of it. All right, I'm going to stop here because I'm running short on time.